Hi everyone, welcome back to Made Easy Academia. So please don't forget to like our videos, share so other too can be able to benefit from these online tutorials. So please, and at the same time, in case if you need our help, either you have a questions related to either maths or physics or chemistry, you can kindly contact us through our channel. So thanks for watching. So today, our main topic for today will be based on calculus. A lot of students fear this calculus. They'll be saying calculus, calculus, calculus. But mind you, since you have yours here, by God grace, we are going to break it down into the simplest form so that you'll be able to understand what we are saying. So our main focus here is both differentiation, at the same time integration. So those are the things that we are going to talk about, because in calculus, the answer under this, just like a question under differentiations, is the answer under integration, and at the same time, the answer under integration is the question under differentiation. Meaning, if you are talking about calculus, you need to know or we need to learn the derivative, which is differentiations, at the same time integration. So I will start with this. We have many methods under these differentiations. At the same time, we have many methods under integration. So I will break them down to the simplest form. Each method that we have, each function that we have, I will list them and we are going to take them one after the other. So let's first talk about differentiations. For this part, we have like almost, I will break it down so that you can be able to understand what we are trying to talk about here. We have like almost 4 or let's say 11 different functions we'll be talking about. The first one, we talk about general method. This general method is a rule that guided differentiation. That how can we differentiate? So for example, we have general method. We talk about function of function. The function of functions, in some situation, they call it a chain rule. We call it chain rule. That chain rule, we have first principle. Then apart from first principle, we have product rule. Then we have quotient rule. We have trigonometric function. We have implicit function. We have logarithm function. Even we have exponential function. We have polynomial function. At the same time, we have maximum and minimum point function. So those are the ones that we are going to be talking about under only differentiations. You have to take note of this. So if you be able to understand a lot here, you can be able to understand the concept of the other one too as well. You see, can you see from there? Okay. So now I will be taking all these one after the other. I will break it down. The first one that we mentioned, general method, is just a rule of how can we differentiate. Then the second one is a function of functions. So in some textbooks or some material, they call it a chain rule. The other one we have what we call the first principle. After first principle, we have what we call product rule, we have quotient rule, we have trigonometric functions, implicit functions, at the same time, logarithm functions, exponential, polynomial, and maximum and minimum point function. So I will be taking them one after the other for only under differentiation. So let's go. Now, let's take them one after the other. So let me just give you the simple clue on how to differentiate. Differentiation just like when variable is changing. That's what we are trying to talk about. When variable is changing. So how are we going to do that? Differentiations, derivative. Let's first talk about the first one for the general for the general method. General method, that is how the rule that guided differentiation itself. Look at it. Let's say I have something like this: y is equal to p, or let's say y is equal to x. You can see what I have here is y, what I have here is x. If I want to do this, I can have dy dx, just like differential of y to differential of x. So let me give you the law that guided that. The law is, if I want to differentiate the power, that is exponential, exponent rather, we come to the front and we are going to subtract 1 from that power itself. For example, if we said if y is equal to x raised to the power of n, let's assume I want to find dy dx. You look at the way, because if you get the concept of d, then you'll be able to know how to differentiate. I want to find dy dx here. So the law is, whatever power we have, the power will come to the front. So when the power comes to the front, we see assume that the power is there. So if you subtract 1 from the power, you're just going to subtract 1 from the power. It cannot be 2, it cannot be 3. It's always what? It's always 1. So for example, if I want to do this now, I can have this one to be dy dx is equal to, you can see the power here is n. So if the n come forward, we have nx. So you can see the power we still have here is n. That's n minus 1. Meaning, if you are differentiating, the power will come to the front, and you are still assuming that the power is there, and you'll be subtracting what? You'll be subtracting 1. I hope you are following it right. So that's just the simple law of how we are going to differentiate. Let me repeat myself again. Let's say I have something like y is equal to x raised to the power of f, and I want to find dy dx. Look at the law. You see the power that we have here is f, isn't it? Now, so the power will come forward. So when the power comes forward, we are going to still subtract 1 from the power itself. So here, that means that we have dy dx is equal to, so the power I have here is f, the power will come forward, that's going to be f x, then f minus 1. So this is the law. For now, we are going to differentiate. So let's see some examples. So any question you are solving, you have to master this law. Just like a simple logic, or now you can differentiate. The power will come forward. So when the power comes forward, we assume that the power is still there, and we're subtracting what? We're subtracting 1. So it cannot be 2, it cannot be 3. No matter how the question comes, you only subtract what? 1. Fine, good. So let's see. Maybe they said, let's look at this. They said find differential of the following. Find derivative. You can call it derivative. Find a derivative of the following. Find derivative of the following. 1, he said y is equal to x4. 2, y is equal to x10. 3, y is equal to 2x5. 4, y is equal to x5 plus 4x4 plus 3x cubed. 5, y is equal to, let's say, 2x squared plus 5. 6, let's say we have y is equal to 4x squared plus 5x plus 10. So now let's look at this simple question. It says to find the derivative of the following. So the first one, they say y is equal to x raised to the power of 4. The second one is y is equal to x raised to the power of 10. The third one, 2x5. So I will be taking them one after the other using the same law I just mentioned now. So the first one we are given there, they said y is equal to x4. So now I want to find differential of it. I want to find dy dx of this. So as I told you earlier, so here we have y, we have x. So here we have dy dx is equal to, you can see the power that we have here is 4. So I told you earlier, the power will come to the front, and we are going to subtract 1 from the power itself. So if the power comes to the front here, and we have 4x, then 4 minus 1. You can see the power we have is 4. So when the 4 come forward, then we are going to subtract 1 from the power itself. So here I will have dy dx is equal to 4x, 4 minus 1, we are going to have 3. I hope you are following it right. Yeah, fine. So let's look at the second one. Let's say we have, look at the second one we have, they say y is equal to x10. So can you find the derivative of this? You see the same logic? Yeah, good. So down here, I'll just have this one to be dy dx is equal to, so we can see the power we have there is 10. So if the 10 come forward, and we have 10x, then 10 minus 1. So here we are going to have 10x. So 10 minus 1, we are going to have 9. I hope you are getting it right. Good. So now, let's look at the third one. The third one, they say we have y is equal to 2x5. So we can see in this one, the number that we have contain a coefficient, which is 2. So you don't need to worry. You know, if this coefficient is not there, we are expecting the answer to be what? Yeah, 5x4. So meaning if I'm bringing the number here, it will multiply the one that we have initially. It's not as if we are going to throw out the one that we have beside that x. The one we are bringing here will multiply the coefficient we have before differentiating the function. So down here, I can have this one to be dy dx is equal to, now the power is 5. The power come forward, and we have 5 times 2. Either we have 2 times 5 or 5 times 2 is still the same thing. 2 times 5 and 5 times 2 is still the same thing. So x raised to the power of 5 minus 1. You can see, assuming if this 2 is not there, I know the answer is going to be 5x4, right? But since 2 is there, so the moment I'm bringing that 5 forward here, it's going to multiply the number we have initially, which is 2. So 5 times 2. So here we have, 5 times 2, of course, we are going to have 10x, then 5 minus 1, we are going to have 4. I hope you are following, right? Yeah. So let's look at the third one, the fourth one. They said we have y is equal to x5 plus 4x4, 4 raised to the power of 4, plus 3x raised to the power of 3. You can see in this case, we have like 3 values, 1, 2, 3. Meaning, I will differentiate them one after the other. I will find the differential of the first one, the second one, and the third one. So here we can have dy dx is equal to, differential of x5, what are we, x raised to the power of 5, what are we going to have? Yeah, so that's going to be, did I need to show that one also? Okay, let me show it. Differential of x raised to the power of 5, 5 come forward, that's going to be 5x, 5 minus 1, you understand, right? Then plus, the second one we have is 4, right? That's going to be 4 times 4x, 4 minus 1. Then the other one, the third one we have is 3 times 3x, 3 minus 1. Even if it is more than this, you will solve them one after the other. So here we can have this one to be 5x, 5 minus 1, that's going to be 4, isn't it? Then plus 4 times 4, we have 16x, 4 minus 1, we are going to have 3, plus 3 times 3, we are going to have 9x, 3 minus 1, we are going to have 2. I hope you are following that. You can see that calculus is very nice, right? Yeah, good, fine. Let's just be solving them, but I will not be showing it again. I will do this so that to save our time, I'll just be, instead of having x4 now, just write the answer directly. I hope you are okay with that. Yeah. Now, let's look at this. Now, 4. So, in the fifth one, they said y is equal to 2x squared plus 5. It's still going to be the same way of how we solve the other 4. So that means that we have dy dx, or let me just also tell you this one. In calculus, the division of a constant, that is, the division of a constant, the differential process, the variable you are differentiating with respect to is always 0. For example, you can see here, assuming I want to find dy dx here. So if I want to find dy dx here, since this one doesn't have any x, it's going to be 0. How is it 0? If I have 6 is nothing but 6x raised to the power of 0, right? If I differentiate that one, this come forward, and we have 0 times 6x, 0 minus 1. So 0 times 6, that's going to be 0x minus 1, and this is nothing but 0. So the differential of a constant is always 0. I hope you are following, right? So now here, if I do that one, okay, let me show you this one too. 2 times 2, the power come forward, 2 times 2x, 2 minus 1, then plus the differential of 5, and we have 0 because it's a constant. So here we have dy dx, 4x, 2 minus 1, and we have 1 plus 0. So this is nothing but 4x. I hope you are getting it right. Yeah, good. So now, let's look at this one also. Or should I just leave this one as exercises? Yeah, fine. So you can just leave that one. Let me just tell you the answer. If you do that, or let me just quickly do it here to save our time. The y dx of this, the differential of this, I will have 8x then plus 5. It's just a simple differentiation. I hope you are getting it right. So let's bring more examples on how they can complicate this general method. Maybe just let me find the derivative of the following. Let's look at this, another one. The first one, they said y is equal to x raised to the power of 3 over 2. The second one, y is equal to root x. The third one, y is equal to 1 over x square. Anyone? The next one, they said y is equal to 3x minus 1 over 2x. So let's see all this problem one after the other. I want to use the general method to solve this one. So now I will take them from the first one. From the first one, they say we have y is equal to x 3 over 2. You can see the only difference between this and the one we solved earlier is that the power of these come in form of fractions, but still the same thing. So here we are going to have, as usual, we have dy all over dx is equal to, now the power is 3 over 2, to come forward as usual, that's a 3 over 2x, then 3 over 2 minus y. You know, I told you, you will bring the power forward and you subtract 1 from the power itself. So here, I can have this one to be 3 over 2x, 3 over 2 minus 1. You know, this is a fraction, 3 over 2 minus 1. So let's say of 2 and 1, that's going to be 2. 2 into 2 is 1. 1 times 3, and we have 3. 1 into 2 is 2. 2 times 1, and we have 2. Then 3 minus 2, of course, we are going to have a 1 all over 2. I hope you are getting that one right. So here, we are going to have 1 all over 2. So if you like, you can still go further with this. You know, under indices, if I have root a, is nothing but a raised to the power of half, right? Under indices, root law indices. So now if I have this, I can write this one as a 3 over 2x root of x. It's still the same thing. I hope you are getting it right. Yeah. Good. So let's try the second one. The second one is said y is equal to root x. So this is root. Just like what I mentioned here, if I have root is nothing but half. So here I can write this one as y is equal to x raised to the power of 1 over 2. I hope you are getting it right. Yeah, fine. So let's differentiate now. This is y and this is x. So here we have dy all over dx is equal to, you can see the power which we have is 1 over 2. If it comes forward, that's going to be 1 over 2x 1 over 2 minus 1. You get it right? So here we can have dy dx of this to be 1 all over 2. You know, this is fraction. 1 over 2 minus 1. Of course, we are going to have, I hope you know why I got minus 1 over 2. Okay, let me show you. This is it here. 1 over 2 minus 1. Just a simple fraction. 1 is the same thing as 1 over 1. XM of 2 and 1. Any problem? XM of 2 and 1. And we have 2. So 2 into, that's going to be 1. 1 times 1, and we have 1. 1 into 2, we are going to have 2. 2 times 1, that's going to be 2. So 1 minus 2, and we have minus 1 over 2. So that's how we have minus 1 over 2. So I want to be breaking them down one after the other, so that there won't be any issue with that. Okay, so now here, you can have this one to be 1 over 2. You know, if you recall under indices as well, if I have a raised to the power of minus m, you know, if you have a negative as a power, this is nothing but 1 over a raised to the power of m. I hope you remember this one, inverse law under indices. So that's what I'm trying to apply here now. Since I have x raised to the power of minus 1 now, I can see this is the same thing as 1 over x raised to the power of 1 over 2. You get that one right? So 1 times 1, that one can be 1, then 2 root of x. I hope you are getting it right. Yeah, good. Let's move further. Let's see the next one. The next question, they said that y is equal to 1 over x squared. So being any powers, the power can be 2, can be 3, can be 4, any power they bring you. Either it is 4 or 5 or 6 or 7, just apply the same thing. Apply the law of indices, because you can see that's the beauty of mathematics. If you are doing one topic, you can end up in being in another topic. So you just have to master the law. Under law of indices, if I have 1 over 2 raised to the power of 5, for example, you know, for me to convert this is nothing but 2 raised to the power of, you can see the power is positive, that's going to be 2 raised to the power of minus 5. I hope you are getting it right. Are you getting it? Yeah, fine. So now, if I have 1 over x squared, this is nothing but y equal to x raised to the power over minus 2. You can see the power we have is 2. So if it is any another number, if it is 3 or 4 or 5, I will apply it. I will solve it the same way. So here, y and x, I can have this one to be dy dx is equal to, now the power is minus 2. That's going to be minus 2x, then minus 2 minus 1. Do not be confused that the power here is negative or negative. Of course, because the initial one we have for the power is minus 2. And we know the moment we bring out the power to the front, we are still going to subtract 1 from the power itself. So that's why we have minus 2 and minus 1. So here, we can have this one to be minus 2x minus 2 minus 1. Just like, we have treated a lot of things about this simple addition of numbers that have negative, negative, or negative, positive. So in case if you missed the previous video, you can watch that one as well to learn how to combine when we have negative, negative, or positive, positive together. So now minus 1 minus 1 and minus 2 minus 1 is like we are converting the two together. So minus 2 minus 1, of course, and we have minus 3. So now I can still rewrite this one. This one can just be minus 2 times, if you have x raised to the power of minus 3 is nothing but 1 over x raised to the power of 3. So 1 over x raised to the power of 3, right? So this times this, I can just have minus 2 over x raised to the power of 3. So now, the next questions for number 4, they say y is equal to 3x minus 1 over 2. So to make it this one more better, let's just change this one, because you can see this one is in form of fractions, just like the way we do here. When we have a fraction, we quickly change it to normal one. So now let's do this one here too. That means I can rewrite this as 3x minus 1 over 2x raised to the power over minus 1. Do you know why I got minus 1? If I have 1 over x, for example, 1 over x, the power we have there is 1, right? So the moment I change it, it's going to be x raised to the power over minus 1. So now, since I have 3x, the power of this one is 2 is also 1. So let's differentiate this one now. So we have dy dx is equal to, as usual, the power will come to the front as usual. That's going to be 1 times 3x, 1 minus 1, minus 1 all over 2. So the power is going to come forward, times minus 1x minus 1 minus 1. I hope you get it right. Let me come again. Let me come again for this. I have dy dx. Differential of 3x is going to be 3. How? The power come forward. That is 1 times 3x, then 1 minus 1 minus 1 all over 2. So if this one 2 come forward, that we have times minus 1 x minus 1 minus 1. So here, we have this one to be 1 times 3. We are going to have 3x. 1 minus 1, that's going to be 0. Minus times minus, we have plus 1 over 2 times 1. We are going to have 1 over 2x minus 1 minus 1. We are going to have minus 2. I hope you get it right. Now, so, anytime number raised to the power of 0, that's going to be what? 1. So 3 times 1 here, we have 3 plus 1 all over 2. I can change this one back to 1 all over x squared. So now here we can have 3 plus 1 times 1. We are going to have 1 over 2x squared. So can you see that? So anyhow they bring it, you can just quickly apply that of a general method. So let's see another varieties of questions using the same general method. Let's look at another one. They said, find the derivative of the following. Maybe first one, y is equal to, let's say 3x5 plus 4x4 plus 3x cubed plus 2x squared all over x squared at x is equal to 1. The second one, they said y is equal to root, let's say, cube root of x squared. So now, let's look at this one too as well. We are still going to follow the same process, the same method. Now, the first one, you can see it coming from fractions. So before we do this one, it means we are going to use this x squared to divide all this one one after the other before we even find the derivative. So how? This will be y is equal to, so for the first one, we have 3x5 over x squared, plus the second one, we have 4x4 over x squared. The third one, I have 3x cubed over x squared. The next one, we have 2x squared over x squared. So how did I do that? I use x squared to define all these values one after the other. So here we can have this one to be y equal to, this is x squared, this is x5. If x squared cancel x5, here we have x5, here we have x squared. If you remove 2 from 5, what are we going to have? Yeah, x3. So here we have 3x3 plus this one too, we have 4x squared. Can you see that? Because if 2 remove 4, we are going to have 2 plus this one 2. This is 2. This is 3. If we remove 2 from 3, we have 1. It's going to be 3x1. I hope you are getting the way I'm doing it. This is x cubed over x squared. So meaning this means x over x, just like a subtractions. So we have 1 left here. So now you can see here x squared cancel x squared here. What I have left here is 2. So now I can now find the derivative of it. So here we have dy dx. Normally differential of 3x cubed, as we mentioned, differential of 3x cubed, if 3 come forward, and we have 9x squared. I hope you get that one right. I'll show you, I will not be showing that one again. Just like this, the power come to the front, 3 times 3x, 3 minus 1, and that one is at 9x squared. So differential of 4x squared at the same time, and we have 8x. You get that one? Yeah, good. Differential of 3x1, of course, we are going to have 3, and differential of 2, that's going to be 0. I hope you are following right. Yeah, good. So they now said at x is equal to 1, meaning after we differentiate it, we should put the value of x to be 1 here. So at x is equal to 1, so here we have at x is equal to 1, meaning in this result, if our x is equal to 1, so that means that we have dy dx is equal to 9. X is 1 now. That is 1 squared plus 8 bracket of 1 plus 3. So 1 squared, it means 1 times 1. And 1 times 1 is 1. 9 times 1, and we have 9. 8 times 1, and we have 8. Then plus 3. Can you see that? You just have 1 square. 1 square simply means 1 times 1. We are going to have 1. So 9 times 1, I have 9. 8 times 1, we have 8, then plus 3. So 9 plus 8, as usual, we know 9 plus 3 is going to 9 plus 8 is going to be 17. Then 17 plus 3, we are going to have 20. So that's all about that. So let's look at the second one too as well. They said y is equal to, let me do it here. Y is equal to, sorry, let me put here so that we have x squared. So it's like if I have y is equal to root x. I told you if you have root x, you can write that one as x raised to the power of 1 over 2. You remember that? This is so meaning if I have y is equal to cube root of x, if I want to write this, is nothing but y is equal to x raised to the power of 1 over 3. I hope you are getting it right. So now I want to write this one as well like that way. So if I want to write that one here, I can have y is equal to x squared. So if I put it that way, this one is going to be 1 over 3. You understand? If there is no 2, I will just have x raised to the power of 1 over 3. But in that root, we have 2 there. So that's why we have 2. So here we can have y is equal to x raised to the power of 2 times 1. What you are going to have is 2 over 3. I hope you are getting it right. So good. So let's differentiate this one now. That means that we have dy dx is equal to differential of this come forward as usual, 2 over 3x, 2 over 3 minus 1. So 2 over 3 minus 1, that's x here is 3. So 3 in 3, we are going to have 1. 1 times 2, that's going to give us 2. 1 in 3, we are going to have 3. 3 times 1, that is 3. Then 2 minus 3, we are going to have minus 1 over 3. So here that means that we have this result to be 2 over 3x, 2 over 3x. Then here we have 2 over 3 minus 1, so we have it to be minus 1 over 3. So you can still go further by changing this. This can be written as 2 over 3 times 1 over x raised to the power of 1 over 3. We mentioned earlier under the law of indices that if you have a negative, we can just use our inverse. So 2 times 1 here, and we have 2x, 3, then cube root over x. Have you get that? Now, fine. So now, so that's all about the general method. So let's see another method. We have what we call chain rule, which we call function of function. Chain rule.